Welcome to 3D bar plots part 2. So here we have an example of a 3D bar plots, but of course the problem here that you may have noticed is that essentially it's just these 2D bar plots that are on a 3D plane. So let's say we want to have these be actually 3D bars as opposed to 2D bars on a 3D plane. So just take a look here. What we have is the above graph used the bar method with 3 parameters which are x, y, and z, whereas the bar 3D method takes 6 parameters, at least minimum, of x, y, z, then dx, dy, and dz. So the x, y, and z are for the positions of the data, whereas the dx, dy, and dz are for the dimensions of the data. Okay, so what I'm going to start off with is that you need to import, of course, the Matplotlib and NumPy modules, but also from the MPL toolkits, import the Axis 3D. So you should have this MPL toolkits module by default when you have the Matplotlib installed. And of course you have Matplotlib installed by default with the Anacron distribution. Alright, so what we're going to do is have x equals mp.array, and then we're going to have a range of, let's say, 0 to 3, and we'll do a float. So we'll have them as floats as opposed to integers, as you can see here. Alright, then we'll have likewise y equal to x.copy, and we do y. You can see we get the exact same output here. Okay, it's just a one-dimensional array. Then we're going to have the positions here for x and y, so xpos and ypos equals mp.meshGrid x and y respectively. Then we do xpos. Now we take a look at ypos. You can see that they're actually different values here. Okay, so they have the same dimensions, two-dimensional, but different numbers inside them. And then we'll have the z equals mp.random.rands of 3, 3. So that's going to be a two-dimensional array composed of 9 values here. So z, as you can see here, has these 9 values, which are these very long float numbers here, composed of all these decimal numbers. Right, so let's say we have xpos equals, at the moment we know it's just a two-dimensional array, but we're going to convert this into a one-dimensional array. So that's going to be xpos.flatten, then xpos, and as you can see now it's converted into a one-dimensional array. And similarly we'll do the same with ypos. ypos.flatten, like so. Okay, and then we're going to have here colors, and we'll use this later on, not straight away. So we'll have B for blue, G for green, and we'll also have, let's say, crimson, which is a pretty intense color. We'll multiply that by 3. So it's going to be a total of 9 colors, 3 of which are repeated. Okay, so then we're going to be having zpos equals np.zeros like xpos, or it could be ypos, because what we get here, it should be like, what we get here is these float values which are just zeros. Right, and then we're going to have here the dimensions now for our data. So 0.5 multiplied by np.ones like zpos, so dx. As you can see here, we do, let's say, 2, but I think it's reasonable to keep it at 0.5. And then we'll have dy equals dx.copy, just like we had before with the y equal to x.copy. So of course, going to have the exact same values here. And then we'll have dz equals z.flatten. So we just take a look. Z, of course, it's a two-dimensional array with these float values. And then we do dz. You can see it's one-dimensional. Right, and then we're going to have here fig equals plt.figure. Fig size equal to, let's say, for me at least, 7.5. You can change the value if you like something larger or smaller. And then we'll have x equal to fig dot add subplot 111 projection is going to be, of course, equal to string of 3D, and then we'll have x dot bar 3D, and I'll do shift and tab. You can see I have x, y, and z, which are the positions, and then dx, dy, and dz, which are going to be the dimensions of our data, then the color, and we'll put the colors in later. Right, so I'm going to have here, it's going to be x pos, y pos, z pos, dx, dy, and dz. And then we'll have plt.show. And we'll just take a look at the output by scrolling down so we can see it in its totality. Okay, great. So if I run this again, you're going to get different outputs, but with just this default blue color that we have here. Right, so let's say, for instance, I want to change the heights according to what I want. So as opposed to just it being randomly generated, because we're using a rand method here. So what I can do instead is, let's say, I define z again, but below this one. So z equals, this has to be an array, so np.array, and it has to have a two-dimensional array. So we're going to have two square brackets here. And the first one's going to be, let's say, 0.4, 0.5, and 0.4. And the next one's going to be, let's say, 0.9. It could really be anything. It's entirely up to you. I'm just putting these values in arbitrarily. And then we'll have in here 0.2, 0.2, and let's do 0.2 as well, just for demonstration purposes here. Right, so now this is going to be constants. So you're going to have some that are 0.2, some that are 0.9, etc. So I run this and see what we get. Right, so every time I run this, you can see it's constant now. It's no change. And I can just change, let's say, for instance, this one here, and maybe make it a little bit higher actually. So 0.9. So I'm going to make this, let's say, 1.2. So as you can see, it's a little bit higher. It's not terribly noticeable, so I'm going to actually make this a little bit more, like so. Okay, so that stands out a lot more now. Let's say I want to change the colors as well. Simply go to where the bar 3D method is, and then simply do, it's going to be color equals colors, as you can see here. Alright, nice. So let's say I want to make something a little bit more meaningful than this. So what I can do is, let's say we take our time, and I'm actually going to create something entirely new, just to reinforce our understanding of how to do this. So we'll have, like before, np.array range, let's do free float. Okay, then we'll have y equals np dots. So that's going to be, excuse me, x dots copy, and then we'll have here x pos, y pos equals np dots. Mesh grids, x and y has to be in that position, otherwise it'd be an error. Then we'll have x pos. Okay, and then we'll go to the z equals np dots array. We're going to create our own data. So it's going to be 0.23, 0.21, 0.3, and then we'll have here 0.4, 0.5, 0.6, and 0.7, 0.6, and lastly 0.9. Alright, so this data I'm not treating arbitrarily. I'm going to have some meaning to it. And then we'll have colors just like before. So I'm just going to put it right, just type it all up again really, just so that we don't make any mistakes here. Okay, so just have to undo that. That's going to be multiplied by 3. And I'll have x pos equal to x pos dot flatten, just like before. So this should eventually sink in. Y pos dot flatten. It does seem, at least initially, a little bit strange. Dot zeros, like x pos, z pos, just all those zeros here, of course. And then we'll do dx equals, it's going to be our dimensions for our data. And actually, let me just return back to this just temporarily. So we can take a look here. Let's say I want to change this to 0.2. So you can see they're a lot skinnier. Now if I go back here, 0.9, they're going to be, whoops, they're going to be a lot fatter. as you can see here. So they can be really skinny, or they can be really wide, as you can see here. So that's the reason why I keep it at 0.5. Alright, so just returning back to our code here, I'm going to again keep it to 0.5 multiplied by np.ones like zpos, and then dy equals, of course, dx.copy. Then we'll have here fig equals plt.figure, then x equals fig.add subplot 1, projection, of course, is going to equal 3D, and then we'll have labels equals, this is going to be university, so Harvard, Yale, and I think this is how you spell it, Berkeley. And then we'll have here, I'll leave that for now, it's going to be the legend. We'll leave that for now, it's a little bit complicated. And what I'm going to do is have bar 3D, xpos, ypos, zpos, dx, dy, dz, and it looks like I'm missing the dz, so I need to do that as well. So dz equals z.flatten. Alright, so just make a little bit of space there. Okay, so that's all the calculations for our data there. And then here we'll have color equals colors, so just like before. But we're going to modify this quite a bit in a moment. plt.show, and I'll scroll down. This should be flatten. Okay, great. So it's a little bit more distinct now. Okay, so let's say I want to add in something for the X, Y, and Z axis, and also a title and a legend, and making this a bit more meaningful essentially. So let's say I do right here, we'll have a title, so x set title, that's going to be, let's say, university salaries, and we'll do, let's say, a font size equal to 20. Run that. Okay, so we've got our university salaries, and then I'm going to just start with the x-axis. So just scroll down here, and then we'll work on the other axes, the y and z. So we'll do x.set x tick, hit tab, so we've got tick labels, and we'll have just 3, 2, and 1. Run that. So you can see I have 3, 2, and 1 here, but I want to change the position, so what I can do is it's going to be x.set x ticks, it's going to be range 3, like so. Okay, and I'm going to have ax.set x label, it's going to be ranking, and just run that. Okay, so I don't really like the position there, I'd like to move it a little bit further away. So you can do label pad equals, let's say, 7, like so. So it's a tiny bit further away. Right, so you've got the rankings here for the universities. Alright, and then I'm going to have here the Y, so I'm going to make that separate, just so that we don't get confused here. So set Y ticks, it's going to be range 3, run that. Okay, so we've got 0, 1, and 2. Right, so let's say I want to have the professions here, so they're going to be ax.set y tick labels. This is going to be admin. This is just arbitrary, I'm making this up, so I'm not too sure what the salaries would be, but I'm pretty sure that lecturers would get paid the most out of these three. Okay, so we've got the admin, security, and lecturer, and then we're going to have here ax.set y label. It's going to be profession, label pads equals, let's say, let's do 7 as well. Label pad. Right, okay, make that a little bit further away perhaps, so we'll do 8, or maybe 10. Okay, it's a tiny bit better. Alright, and then I'm going to have here for the Z, so I'm going to change this to all the way from 0 to 80,000. So to reflect these salaries, that's going to be ax.sets z tick labels. It's going to be 0, 20,000, 40,000, 60,000. It's going up by 20,000 each time, and then lastly 80,000. 80,000, yeah, that's fine. Right, then we want to move this up. So what I can do is ax.sets z ticks mp.arange 0.0. You can't do this with the range, you have to do it with the numpy's version. You can't have float numbers in there. And then ax.sets z label, we'll do salary slash $sign. Right, just scroll down so we can take a look at the outputs. Okay, that's not too bad, but I don't really like the fact the salary is so close and so on. But we'll worry about that later. And then we're going to have a legend. So a legend is actually quite complicated to do within a 3D plots. So what we'll have to have here is, firstly, we'll do xleg, just short for xlegend, equals plt dots. So we'll just do run of them for the time being. So rectangle, then shift and tab. So you have the x, y, the width, the height, the angle. So all we're going to do here is shift and tab again. It's going to be 0, 0, and then we'll have here 1, 1. So for the width and heights, so I always keep them like that. Then we'll have B, and then we'll have here Y, like just like before, plt dots rectangle 0, 0, 1, 1. You can do a multi-cursor if you wanted to. G, and then Z leg equals plt dots rectangle 0, 0, 1, 1 for the width and heights, and FC equals, of course, crimson. Right, then we have to actually have the legend itself, so we'll do ax.legend, and you have to put it in square brackets here, so circle, or rather parentheses then square brackets, and that's going to be x leg, y leg, and z leg. So it's quite a lengthy process. Then we have labels, which is going to be from, we scroll back up here, labels, which is Harvard, Yale, and Berkeley. And then we'll do font size equals, let's say, 12, and lock. At the moment, I'll just keep it as 1.1 and 0.4. And that's okay, great. So you can see that we have our legend here. So let's say we want to actually view this as a 3D model. So at the moment, okay, we do have them as these 3D plots, and they are 3D bars, but we're not treating it as an actual 3D object, which means that we can actually rotate it. So the way to do that is going back up to the very top here. I'm going to put it at the very top, and it's going to be a magic function for Jupyter Notebook, and that's going to be Matplotlib. It's going to be nbag. Run that. As you can see here, we have it a lot clearer now, a lot larger, but note that the actual legend has moved to the side, and we'll address that problem in a moment. So what I can do, if you can just scroll down here, you can see that I have various options, and note that some of these unfortunately don't work. So the home, the left and right arrows don't work, but these do. So these cursor one, this button here, and this button here do work. Right, so what I can do is just click on this, and then I can actually rotate it around. It takes some time to adjust, as you can see here. So I'm just rotating this around. And what else I can do is I can click on this button here, this download plots, and it generates a PNG on a new web page. You can be online or offline, and you can simply right click and save image as. Alright, I'll go back here, and what I can also do is zoom in. So essentially treats the pan zoom in like the fig size. We can zoom out as well. It takes some time to adjust, of course. Alright, then what I can do also is zoom in. So I don't really need to do this, but it's useful if you have, for instance, something that's highly detailed as a 3D plot. So all you have to do is simply right click and then you go up or down. So going up, I'm going to go down. Okay, so I'll just leave it at that. And let's say I want to address the issue with this legend. I'll just click that to stop the interaction. Scroll up, and what we can do is just change this to best fits. So it's going to be a string. So best. And now if I go here, you can see I can see the legends. And if I scroll it around, it's not going to affect the position. It stays constant as to where it is. Alright, so that pretty much concludes my lecture. I hope that's been insightful, and if you have any questions, feel free to ask in the Q&A. Thanks very much.